Welcome to the series of VCAA Math Method 2021 exam papers. The first paper consists of 9 short answer questions, while the second paper consists of 20 multiple choice questions and 5 extended response questions. In exam paper 1, knowing the exact values of circular functions as well as function transformations are challenging to most students. In exam paper 2, many students have difficulties in finding the domain and range of functions, understanding the exact requirement of questions, as well as tackling the questions that require explanation. We will demonstrate and explain all the questions in both paper 1 and 2 through 11 videos, and we hope these videos will be helpful to you. Welcome to the first part of VCAA Math Method 2021 exam paper series. In this video, we will present exam paper 1 questions from 1 to 5. It is worth mentioning that students generated well in question 4A apart from labeling the x and y intercepts. However, most students did not do well in question 4B. They attempted to solve algebraically instead of using the graph from part A, and only obtained the lower bound of inequality. Function transformations remain challenging for many students as shown in question 5B.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Math Method 2021 exam paper series. The first exam paper consists of 9 short answered questions, while the second exam paper consists of 20 multiple choice questions plus 5 extended response questions. As for exam 1, we separate 9 short answer questions into 3 videos to explain them in details, and hope you will find some help from these videos. As it can be seen, the requirement of question 1a is to differentiate the function of 2e to the negative 3x, while question 1b is to evaluate f prime of 4 given that f of x equals x multiplies square root of 2x plus 1. Obviously, chain rule needs to be applied to both questions 1a and 1b, and for 1a, the result of differentiation is 2e to the negative 3x multiplies the differentiation of negative 3x, which gives negative 6e to the negative 3x. As for question 1b, what we need to do is to differentiate f of x first, then substitute the number 4 for x. When we do the differentiation, both product rule and chain rule need to be applied. So f prime of x can be written to the differentiation of x multiplies square root of 2x plus 1 plus x multiplies the differentiation of square root of 2x plus 1, which equals square root of 2x plus 1 plus x over square root of 2x plus 1 after being simplified. After 4 being substituted for x, it equals 13 over 3. Question 3 is to find the expression of f of x given that f prime of x equals x cubed plus x and f of 1 equals 2. Since f prime of x equals x cubed plus x, f of x equals the integral of x cubed plus x, or in parentheses dx, which gives x to the 4th over 4 plus x squared over 2 plus c, where c is an arbitrary constant. The next step is to determine the value of constant c based on the given condition f of 1 equals 2. Hence, 1 over 4 times 1 to the 4th plus 1 over 2 times 1 squared plus c equals 2, which gives c equals 5 over 4. So f of x equals x to the 4th over 4 plus x squared over 2 plus 5 over 4. In question 3, it shows a function g of x equals 2 sine 2x given that the domain of the function is R, which means the whole real number. There are 3 small questions in question 3. Question A is to show the range of g of x. Question B is to find the period of g of x, while question C is to solve the equation 2 sine 2x equals square root 3 for all the real numbers of x. As for question A, since the range of sine 2x is within a closed interval from -1 to 1, obviously the range of g of x is within a closed interval from -2 to 2. As for question B, since g of x is a sine function, its period equals 2 pi over 2, which is pi. Question C is to find a general solution for the equation of 2 sine 2x equals square root of 3. So the expression of general solution for sine function is applied here, which is absolutely a cost-effective way to answer this question. So remember the general solution formula for trigonometry functions as well as how to apply them are quite essential. Now, the expression of the general solution for sine function here gives that 2x equals n pi plus -1, or in parentheses to the n multiplies arcsine of square root 3 over 2, which is simplified to n pi plus -1, or in parentheses to the n multiplies pi over 3. Hence, the required general solution for x is n pi over 2 plus -1 to the n multiplies pi over 6, where n is an integer. As for question 4, the first part of this question is to sketch the graph of y equals 1 minus 2 over the result of x minus 2. The second part of the question is to solve an inequality of 1 minus 2 over the result of x minus 2 is greater than or equal to 3. Based on the rule of function, it is a hyperbolic function with 2 asymptotes, x equals 2 and y equals 1. The x-intercept is found by setting the y value of the equation to 0, while the y-intercept can be found by setting the x value of the equation to 0. Hence, the coordinate of x-intercept is at 4, 0, while the coordinates of y-intercept is at 0, 2, respectively. As it can be seen on the graph of the function is sketched and shown on the right. To solve the inequality, all the terms are moved to the left side and then transformed to one fraction. So we have the simplified inequality of 2 times open bracket x minus 1 close brackets over the result of x minus 2 is less than or equal to 0. Solving the inequality gives that x is greater than or equal to 1 but less than 2. Alternatively, this inequality can be solved on the basis of the sketched graph earlier. Since the question is to find the x value range within which y is greater than or equal to 3, it can be observed directly from the hyperbolic graph that y is greater than or equal to 3 when x is greater than or equal to 1. There are 2 functions in question 5, as you can see. F of x equals x squared minus 4, while g of x equals 4 times x minus 1, or in parentheses squared minus 4. Question A is to find x-intercepts of g of x, given that f of x and g of x have a common x-axis intercept at 2, 0. Question B is related to the transformation of f of x. It asks to find the x-axis intercepts of the transformed function h of x, which is transformed from f of x by applying a direction factor and then translated horizontally. Now let's start with question A. Since g of x can be rearranged and factorized to 4x times x minus 2, or in parentheses, the other x-axis intercept of g of x is at the original point 0, 0. Now let's continue with question B. As it can be seen, since f of x equals x squared minus 4, it becomes x over 1 over 2, or in parentheses squared minus 4 after dilation factor of 1 over 2 from the vertical axis being applied, which can be further simplified to 4x squared minus 4. Then the function is transformed to 4 times x minus 2, or in parentheses squared minus 4, which is factorized to 4 times x minus 1, or in parentheses times x minus 3, or in parentheses, after being translated by 2 units to the right. Hence, the expanded h of x equals 4x squared minus 16x plus 12, and the x-axis intercepts of h of x are 1, 0, and 3, 0, respectively. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.